This is the student peer teach problem for the Unit 6 study guide, problem number 8. Remember, as you do peer teaching, bottom line is you need to ask more questions than narrate answers. Ask questions. Don't just give answers. Create dialogue, not simply dictate. Before we do problem number 8, we need to fill out a section in your reference booklet. So find your reference booklet, Unit 6, Proofs on a Coordinate Plane. Because if we're dealing with a coordinate plane, we need to do a review of midpoint, slope, and distance. Find that section. Ready? Proofs on a coordinate plane. The midpoint equation is going to show if something is being bisected. The midpoint equation is going to show if something's been bisected or has a common midpoint. We're going to write out the midpoint equation. The midpoint equation is add the x's, divide by 2, add the y's, divide by 2, comma. In between, it's a coordinate. Write down that midpoint equation. The slope equation will show how a line tilts. Parallel lines, slope equals slope. Perpendicular lines, slope times slope will multiply to -1 or be an opposite reciprocal. Remember, the slope equation is rise over run. Rise, subtract the y's. Over run, subtract the x's. The distance equation shows comparative lengths. The distance equation shows lengths. It can show how two lengths are equal in measure or congruent. Again, the distance equation shows comparative lengths. It can show how two lengths are equal in measure or congruent. Let's go through an example here. If we want to prove that ABCD is a parallelogram, you ask yourself, what do you know about parallelograms? And you should instantly be thinking, OCD. And remember, the first one is opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and the last one was diagonals bisect. There's 5 ways. Let's take a look and see how midpoint, slope, and distance can do something. Ready? We can show opposite sides are parallel. If opposite sides are parallel, then you know it's a parallelogram. So if I were doing a coordinate plane and I wanted to show that these were parallel and these were parallel, I would use slope. Because slope will show that those opposite sides are parallel. If I wanted to show opposite sides were congruent in length, I know it's a parallelogram. That's the second O. So if I want to compare length, I could show that these two lengths were equal in distance, and these two lengths were equal in distance. There, to compare lengths, I would have to use the distance equation. And again, slope equals y minus y over x minus x. Distance is giant square root x minus x squared, y minus y squared. Last, if I wanted to show that the diagonals bisect each other, then I would know it's a parallelogram, like that diagonals bisect. If we draw on the two diagonals, to show that the diagonals bisect, I would have to prove that that orange dot is a midpoint. So I'd have to use the midpoint equation, which is add the x's, divide by 2, add the y's, divide by 2. That's that third one. No equation will show that opposite angles are congruent or that consecutive angles are supplementary. So those two we can't use on a coordinate plane to show parallelogram. But we could show right here one set of sides that is both congruent and parallel. So if the same set of sides were congruent by using the distance equation, and the same set of sides were parallel using the slope equation, I could show the same set of sides were congruent and parallel, then it's a parallelogram. So look at how you can use midpoint, slope, and distance to show things on a coordinate plane. So now let's go to problem number 8. We're only going to get halfway through problem 8. It says we have a quadrilateral RSTV, where R is this coordinate, S, T, and V. You have your coordinates. You're trying to prove two things. We're trying to prove that yes, RSTV is a kite, but we're trying to say it is not a rhombus. So we're trying to prove one thing in the positive and then disprove the other. Okay, so the first thing you have to ask yourself, and this is what you're coaching, get your classmates to ask questions, is what characteristic does both a kite and a rhombus actually have in common? So let's draw a little baby kite, a little baby rhombus, and ask yourself, what do they have in common? What do they have that is the same? They both have diagonals that are perpendicular or make a right angle. So they have that in common. The diagonals are perpendicular. They make right angles in the middle. So both the kite and the rhombus have perpendicular diagonals. So we can't use that to prove it's a kite, because if we just show those diagonals are perpendicular using the slope equation, all you've shown is you have perpendicular diagonals, which means it could be a rhombus. So we have to ask ourselves, what makes a kite distinct from a rhombus? What makes this shape different from this shape? And a kite has consecutive congruent sides. In other words, only the sides that are next to each other are of equal length for a kite. Whereas a rhombus has 4 congruent sides. So you ask yourself, how do you show congruent lengths, midpoint, slope, or distance? And the question is, to show lengths, you would do distance. So if you found the distance of RV and SRS, and then found the distance of ST and VT, if your math showed that these were equal and these were different lengths but equal to each other, then you would have proven that yes, it's a kite, that because not all four are equal, it can't be a rhombus. Coach your classmates through that, understanding they must do their own math as well as you.